In this video, we'll start about discussing on measures of central tendency. The measures of central tendency of a statistics generally mean an arithmetic mean, geometric mean, harmonic mean, and median and mode. And we have several measures of central tendencies like percentiles, deciles, etc., which I'll cover in the next video. But for now, we'll cover these topics in central tendency measures of the statistics. So there are categorized into central tendency or an average, central average into two categories, mathematical average and the positional average. The name indicates that mathematical is a number and a positional average it specifies which where the particular position was there, particular thing, it defines that way. That's the reason it is called positional average. So in arithmetic mathematical average, a mean is calculated. Again, mean has three different ways to calculate: arithmetic mean, geometric mean, and harmonic mean. And in positional average, you will have median and mode. So overall, this is looking fine, but where these in general life are used or in a day-to-day life are used, you can ask yourself the question. So generally, mean is nothing but an average height of average height of the students in a classroom, etc. Average income of the society, etc., can be calculated on this. And harmonic mean and geometric mean both are used when you have any percentiles or ratios, etc. These methods are used. Generally, harmonic mean used in uh, physical engineering for calculating the speed, etc. And also you have a resistance to calculate the resistance in electrical engineering, physical engineering, etc. Harmonic mean is used. And geometric means generally it is in a compound interest related stock returns, etc. All those, if you have that, geometric mean is used. And coming back to positional average, median, and mode. Median is in a median, the name itself it indicates it's in a middle value. So, what is a middle value of in a data set? What is the middle value of in a data set, etc.? You can identify the middle value. What is the average score of an MSET, average score of all students when compared to the bigger population, something like that. That is called median. Where how do you get a 50%? Meaning, what is a middle value? Generally, when a survey is conducted, most common answers from the public are these people who choose this answer. Something like that is called as a median. Mode is something like a repeated value in a data set which we know about it. A repeated value continuously, you see that. How it is used in our general life, and a product which is sold very frequently. Very frequently a product is sold, something like that. You can understand that very frequently customer is buying that, which is a common product or in a very genuinely and very common, and people prefer to buy certain brand or certain necessity product or something in a day-to-day life, or in a year, in a period, or in a 3 months, or in a patients or something like that. If you do, a mode comes, a frequent ones. So this can be applicable, as discussed, this can be applicable in any industry to know this. So by doing these values and calculating these values, we can identify the usages. So let's move on. So the definitions are, here we go. Arithmetic mean. The arithmetic mean, often referred as a mean, it is a sum of the set of the numbers divided by the number of elements in a data set. Its most common measure, central tendency. So, for example, 5, 4, 3. Three numbers are given. So, what you do? 5 plus 4 plus 3 divided by 3. So, that is called your arithmetic mean, which is represented with the AM. And harmonic mean. So, the harmonic mean is a simple remembrance. It's just a reciprocal of arithmetic mean, meaning you divide it by n, right, number of values, so the n goes up, and the reciprocal of data set. You said 5 plus 4 plus 3. So it becomes 1 by 5 plus 1 by 4 plus 1 by 3. And n value is 3. 3 by 1 by 5 plus 1 by 4 plus 1 by 3. This is nothing but your harmonic mean. That's a formula for harmonic mean, and it's a reciprocal of arithmetic mean, the values in the data set. It is particularly useful when a data is related to rates, ratios such as speeds, other quantities involving averaging over time or in a distance. So this is harmonic, which I told in physical engineering. This term is very much used and very much calculated in that. Next comes the geometric mean. Geometric mean is an nth root of the product of values in a data set. It is particularly used, the data involves which again rates, percentages, ratios, etc. So these are all used in calculating the compound interest, interest rates, relative changes, stock returns, etc. All those will be used in the geometric mean. So these are your arithmetic mean, harmonic mean, and geometric mean, or your mathematical average means, which we covered in the first slide. Next comes the median and mode, which is a positional values. Where is your middle value in your data set? That is the middle value of a set of values when the values are arranged in a ascending order, meaning smallest to the largest value. What is your median value? And mode is a most repeated value in a set of values, which I gave example of. Median is like what is an average income in the society, or middle, most common, or in a survey, what are the most common answer or given by an customers or in a reviewers, etc., in the survey. That is called median. And mode is most product which is sold, which very frequently sold, something like that, most common. These are the critical frequent examples in your day-to-day life. Let's start with mean with the formulas to understand. In this video you will understand the formulas. In the next video I will show you how to calculate the mean, median, mode, arithmetic mean, and geometric mean. Let's understand arithmetic mean. For any data, you have in a grouped data and ungrouped data. Ungrouped data means where you are not given a frequency. Frequency is nothing but a values given for in a class interval or in a number. So grouped data generally will have a frequency, whereas ungrouped data you don't have a frequency. It's just in a data set, normal data set value. So let's understand what is a formula used for the arithmetic mean, which is called mean is represented by AM, and it is called X bar. When you have a dash on X, it is called X bar. So you have values like X1, like 543, which I have given in the previous examples. Like that, you can call it as X1 to 1, X1, X2, X3 to Xn. So the formula is like X1 plus X2 plus X3 up to Xn divided by n. N is nothing but your number of values. So the summation is represented with this value, sigma you call it. Summation x divided by n. Summation of x is nothing but, if you expand it, it is x1, x2, x3 to up to the power up to xn. And n is nothing but number of data sets in given to your, or number of values given in the data set. So this is called your, when it is no frequency is given, this formula is used. So you will find out the mean. Generally x bar is equal to summation of xi by summation by n. And next comes when a frequency is given. You have the data set value and also a corresponding frequency is given to the data set. It could be a class interval, it could be a normal data set also. So if that is given, you need to do the product of x1 into f1 plus f2 into x2 plus f3 into x3, etc. You should do it. And divided by summation of frequency. In we have done in cumulative frequency, we just added, and frequency, cumulative frequency is added and frequency is also added. While calculating cumulative frequency, we have done this. So similarly, when a frequency is given and an arithmetic mean is calculated with product of xi, summation of fi to xi. I is represented as 1, 2, 3, 4, 5, 6, and xi is nothing but data set value. So summation of fi xi divided by summation of fi, meaning it's in a summation of frequency. In the above, we did not do the sum. It's just a number of values. In our ungrouped data, summation of x we did and divided by n we did. Whereas when a frequency is given, it is summation of fi(xi). It's a product of fi(xi) plus and add it all fi(xi), all the values from 1 to n, and then divide it by summation of fi. This is generally a frequency is given, means it is called in a direct method. Now let's go to another formula for this. So why another formula, you may ask? If fi xi values are in a large number, whereas in a decimals and given in a bigger number, where you cannot calculate and the value is more than 6 digits or 7 digits if it is coming, so you will use a mean method in a different way, where you will call it as a plus summation of fi xi by summation of fi. Summation of fi is nothing but your frequencies f1, f2, f3, and xi is same. It's the same. Only thing is a you will add, where a is generally a middle value. So one of the middle value you will take and represent as an a. Assume that's why it is called assume arithmetic mean model. So a you will take and add this a plus summation of fi xi by summation of fi. So when the values are larger and you cannot multiply with your human brain, where you have to use a calculator. So generally in statistics, you are ended up giving you calculator to do it, or in a technical tool or an Excel or in any tool, a technical tool is given to you to use it in your exams to derive the formulas or derive the analysis, etc. That's why this bigger numbers also a statistician or mathematician uses to derive something or to predict something for the future values or a bigger population, etc. is used. So overall, the method is assumed arithmetic mean, and it is a formula which is a plus summation of fi into xi by summation of fi. Next comes the harmonic mean. Formula for ungrouped. For anything, you take anything, ungrouped data and grouped data, where frequency will not be given and you have a formula. Where frequency will be given, you have a formula. So what did we learn from the previous slides? Harmonic mean is a reciprocal of the arithmetic mean. In arithmetic mean, what you did, summation of summation of xi by n. So now reciprocal means it's an ulta, reverse of it. So it becomes the n by 1 by xi plus 1 by x2 plus 1 by x3, etc. to 1 by xn. So n becomes the number of data set values divided by 1 by xi, 1 by x2 plus you do it. This is harmonic formula for an ungrouped data. Next comes the harmonic data for a group data. It's a similar thing. Just you do in a summation of fi and summation of fi by xi. So you do f1 by x1 plus f2 by x2 plus f3. Then you do everything divided by and you do the summation. In fi also it's the same. So here you don't do summation and here you do the summation. So that's the difference between grouped and ungrouped formulas across it. Okay, this is about harmonic mean. Next comes the geometric mean for an ungrouped data. Again, So in this, we have told it is a product of all data set values, meaning xi values, x1 into x2, x3, but exponential of 1 by n. So we spoke about arithmetic mean x1 plus x2 plus x3 divided by n, we said. When we come to a harmonic mean, we said n by 1 by x1 by 1 by x2. For ungrouped only I'm talking, all these. When it comes to a geometric mean, what it happens, it's a product of to the power of 1 by n. So you are doing the product of all the values in a data set and you are doing 1 by n to the power of 1 by n. So this is for ungrouped data. When it is coming from the grouped data, you have learned in arithmetic mean two methods. One is assumed method and direct method. It's the same thing, summation of fi xi by summation of fi. Where summation of fi comes in the grouped data. Whereas in ungrouped data, you don't use the summation of fi. So basically, when my frequency is given. So here, product of all values to the power of 1 by n in geometric mean. In geometric mean, the same formula can be used express of 1 by n summation of log of xi. So how to use in Casio calculator the log xi value, etc. All these I will cover in the while doing the examples. So this is a just for now the remembering factor is the formulas here. So this is for the ungrouped data and grouped data. So it's the same thing. What is that? Fi comes. So summation of Fi log xi by divided by summation of Fi. So it's the same formula where you have told log xi here. If you see log xi, it's the same. And here summation of Fi, sorry, summation of uh, fi into log xi by summation fi. So geometric mean formula for a group data is exponential of summation of fi log xi divided by summation of fi. Fi is frequency of ith class interval, xi is a midpoint of the class interval, and fi is a sum of frequencies. Summation, if you have sum of frequencies, you need to add while practicing the examples and formulas, etc., it will be very clear for you to understand this. Next comes the median. Median is nothing but your middle value. So you may get, if I have an odd values, my middle value is very easy. Odd number of values if I have. 5 if I have, what is a middle value? 2 live here, 2 live here. So third will become your middle value. Where if you have given a even numbers, 4 numbers are given in your data set. So what is that? A middle value? You have two middle values. So two middle values if you have to do value position at n by 2. Two values, two middle values you should do and divide it by 2. If it is an even data set. If it is an odd data set, it's just in a middle value divided by 2. After doing that, what is your formula for the median? L plus lower boundary plus n by 2. N is your total number of observations by 2. And CF, yesterday we discussed about the CF. CF is cumulative frequency. When a frequency is given, median to calculate, we have to have any cumulative frequency. Cumulative frequency is nothing but for the first class interval, the frequency remains, the cumulative frequency remains the same as frequency, but from the second line onwards, you will add the next value, which becomes, for example, 5 and 1 are there in your frequency. Your cumulative frequency becomes 5 as a first value and a second value becomes 6. Like that, you keep on adding till the data set ends. So that is called your cumulative frequency. And you know the F. F is nothing but your frequency. H is nothing but your width of the class interval. When a class interval is given, what is your width? So this all I will discuss how to calculate the class width. What do you mean by H, L, etc. in while calculating the formulas. For now, this is a formula. So what is a median value for ungrouped and grouped data? So for ungrouped, if your data set is given as an even number, two values will be given. You will add two values divided by two. That becomes your middle value. When an odd data set is given, just divided by a middle value by two, it becomes your median. When in a grouped data, for a grouped data, if you have, whereas in a class interval frequency and you are given, you will end up calculating the cumulative frequency, and you have the corresponding lower boundary, which is 0 to 10, 10 to 20. These are called class intervals, which I'll discuss further in the videos. And L plus N by 2 minus CF, central frequency, cumulative frequency divided by frequency into H. H is nothing but width of the class interval, which is width. I will help you in the while deriving the formula on this. For now, grouped data and grouped data median value is this formula, and ungrouped data, it depends upon the even number data set or odd number data set. Next comes the mode value. Mode for an ungrouped data. I didn't cover ungrouped data because it is a most frequently occurring value. For example, in your data set, 243 26 278, which is a word repeated mostly. 2 is your repeated value, so the most repeated value is your mode value. So that becomes your ungrouped data set value. How to find the mode value, which is generally comes in the bits, like objective type questions. So for grouped data, what is the formula for this? L plus F1 minus F0 by 2 Fn minus F0 minus F2 into H. This is a mode formula for calculating the when a class interval is given or in a group data. So L indicates your lower model class, which is called a class interval, and F1 is in a first frequency, F0 is a frequency of a class before middle class, model class, where you will select the mode, highest mode in the frequency, that corresponding above line is called the frequency of the model class is F1, and F0 is the same line, and F2 is below the class. So while explaining the formulas, I will help you to identify what is F1 called, what is F2 called, which value to be taken as an L, which value to be taken as an F1, F0, and F2, and H is nothing but in your class width. So with this video, we will complete mean, median, mode, and means, arithmetic mean, geometric mean, and harmonic mean. So in next class, I will take through all these problems, examples on these related, and next we'll go to the other percentiles, deciles, etc., which are part of the central tendencies of the statistics, or central averages you will call in the statistics. The last one which we need to understand is empirical relationship between averages, between these three: mean, median, mode. Between these three, we should understand, when these three values, mean value is given and median value is given, or mode value is given and median value is given, the simple formula which is given by Carl Person is mode is equal to 3 median minus 2 mean. So just apply median value, where no need to calculate. Directly you have a median value and a mode value is given. Just you apply to this and you get the mode is equal to 3 median minus 2 mean. So like next comes the quartiles, percentiles, etc. All those will come, deciles will come, which I'll cover in the future videos. For now, with this, I will end this video, and you can mark the formulas whichever are given here.